All right, so expanding and condensing exponents. You probably have seen this before, but it's good to go over it. Make sure you're really good with it. So pretty much if we were to take an exponent, right, let's say 5 to the third, we would see that our exponent is our power, right, the guy in the front, and our base is that guy. So we will call this 5 raised to the third power. Maybe just write third like third. Right? So it's 5 times 5 times 5, which equals 125. Okay, so here's an example. We have 2/3 to the third, and then our example over here is going to be -2 to the fifth. So our base, right, is going to be 2/3, and our power is going to be 3. And we can just rewrite that as 2/3 times 2/3 times 2/3. And multiplying fractions, which is a vocab word, right? Multiplying fractions, right? It's just multiply the numerators, you get 2 times 2 times 2 is 8. The denominators, you get 3 times 3 is 9, times 3 is 27, and it's not simplifiable. This is simplified already. So that's what that would turn into. And then over here, our base would be -2, our power would be 5. And this one, you have to be a little more careful with the negative signs. So we have -2 times -2 times -2 times -2 times -2. So when you're putting it in your calculator, you need the parentheses, okay? You need to do parentheses -2 to the power of 5. Oh, the exposure is a bit weird. And I'll give you -32. Okay. So just, getting used to base and power, being able to use those words fluently. Okay, so condensing and expanding, these are vocab words that you're going to see a lot. But condensing pretty much means make things smaller. And then expanding is make things bigger. Maybe a different version for bigger could be like wider. And then for smaller, it could be like skinnier. So pretty much we're trying to make them like less complicated, right? Condensing. And again, this is going to come up in a lot of different ways. Like you can condense exponents, you can condense logarithms. So you just want to understand condense versus expand. So we are going to write the following using exponents. So we're not going to simplify it out. We're just going to write it with exponents. So we have 4 is our base. It's being multiplied 6 times. So we have 4 to the 6th. Pretty simple, right? This one we have -3 times -3 times -3. So -3 to the third. Make sure you have those parentheses. This one is a fraction, 2/5 to the 5th. And then it starts to get a little trickier when there's variables, but it's the same thing, right? So we have x as our base. We're multiplying x 4 times. Yes, nice. X to the power 4th. Here we have 2, so we have 2 different types, right? We have constants, so we have 5 squared y to the 5th. So you could write this as 25, but I just want everything in exponents just to get used to it. And then here we have 3 to the third. Very nice. All right, expanding is just as easy. Why don't you take a second and do those. All right, just to go through it, right, we have 4 times 4 times 4. This would equal 64. Right, we have 2/3 times 2/3 times 2/3 times 2/3 times 2/3, right? Really annoying, but easy. if we were to do this, 2 times 2 is 4, 8, 16, 32, and then, I don't know, 3 to the 5th. It's going to get a little too big for me. 3 to the power of 5, 243. I don't think that's simplifiable, but let's check. 35 divided by 243, math. Nope, it's already simplified. Okay, negative 3, negative 3, negative 3, negative 3, negative 3, keeping those parentheses. We already know that 3 to the 5th is 243, so this is just negative 243. Here we have m, little multiplication signs between there. Here we have 3 times 3, x, so 9, right? And then all those x's. We're just going to leave it like that. And then here, 5 times 5 times 5 times 5 times x times y times y times y, right? Very tedious, but not so difficult. All right, let's go to the back side. So expanding and simplifying. Write the following without using exponents and then simplify, right? Okay, so we want to, there's different things that we could do, right? We're going to multiply them. So without even using the rules that you're going to learn, right, we can just write it all out. So if we do 2 times 2 times 2 times 2, right, so this is the first 2. 2, 2, 2. This is the 5. We can see that it's just 2 to the power of 7. And then 2 to the power of 7, we're going to use our calculator, is 128. But we want to write it like 2 to the power of 7. All right. This one, we have 3 over 4 times 3 over 4 times 3 over 4, right? So this is the first one, and these are these two broken down. But when we multiply them all together, we realize that we just get 3 over 4 to the third. Okay. Here we have negative 4, negative 4, negative 4, negative 4, negative 4. So we just get negative 4 to the 5th. Right, here's the first 2, here's the next 3. All right, probably starting to notice a pattern, but we have y times y times y, first 3 times y times y times y times y, we get y to the 7th, and then we get 2 times x times x times x. That's the first one broken up, and the second one broken up, we're actually going to write this 4 as 2 times 2. Right, 2 times 2, and then I'm going to put the x's down here. So this is this guy, and then this is that guy. So now we see that we have 3 2's. So we have 2 to the 3, x to the 7th. And then finally we have 3, 3, 3, 3, d times 3, d. So we have 5 3's, 3 to the 5th, d to the 6th. All right, so power, right? So first we did multiplying, now we're going to do power. So we just want to break it up. So we have 2 times 2 times 2, right? And then this thing, we're doing it again, right? So remember how if we had like x squared, it's x times x? Well, if we have this whole chunk squared, we do it again. So times 2 times 2 times 2. Then we get 2 to the 6th. Here we have 5 times 5 times 5. We're going to do this 4 times. So this is 1, 2, 3. Pop it up here. 4. We're multiplying all these together. So in actuality, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We have 5 to the 12th. Okay, here, now we're going back to variables instead of constants. We have 4 x's, and then we're doing that twice. So we actually have x to the 8th. here we have 2 times x times x times x. This chunk, we're going to do it 3 times. And we end up having 3 2's and then 9 x's. And then here we have 4, 4, 4, y, y. We're going to do this 3 times. Whew, lot. Okay, so we have 3, 6, 9. We have 9 4's. And then 1, 2, 3, 4, 5, 6, 6 y's.
Thank you, sir.
All right, last one is dividing. So this one we have to think about simplification, right? So once I write it out, you'll see. So let's start with the numerator. So we have 2 times 2 times 2 times 2 all over 2 times 2. So if we think about it, we can actually cancel these, right, when we're simplifying. So those 2 are on the top and the bottom, we cancel it. Those 2 on the top and bottom, we cancel it, and we get 2 squared. And just to prove like why this canceling works, like let's actually ignore the fact that it's exponents and just solve it in our calculator. So we have 2 to the 4th equals 16, and then 2 squared equals 4, and this equals 4, right? And this equals 4. So the canceling works. Whenever you see something on the top and the bottom that's the same, you just want to cancel it. That's a very easy way to simplify. A better way to see that is with numbers, but it also works with variables. So we have 5 x's on top. We have 3 x's on bottom. These 3 cancel, so we're only left with 2 on top and nothing on the bottom. So we have x squared, right? Okay, here we go, a little more interesting. So we have 10, and then we have x, 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 4, 5, 6 over 2, x, x. Okay, so for this one, these 2 cancel, and then this will simplify to 5 over 1. We divided both by 2. So we're left with 5, and then 4 x's on top, and then all over 1, which just equals 5x to the 4th. Oh, wait, I counted this wrong. 1, 2, 3, 4, 5, 6, 7. 5x to the 5th. Okay. We have 3, y, 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 y. Right, so we're expanding right now. 12, y, 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 y. And then we're simplifying. And this divided by 3 is 1. This divided by 3 is 4. So we get y, 2 y's on top and then a 4 on the bottom. And then finally we get this one. It looks messy, but it's not that bad. Right, we have 2, 2, 2, 2, 2, x, 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 and 5 y's. 1, 2, 3, 4, 5, all over 2, 2, 1, and then a y. Okay, so cross out a y there, cross out 3 x's there, cross out 2 2's there. We are left with 2 to the 3rd, 1 x on top, 4 y's. So in all these examples, there was more on top than on bottom. So I'm just going to give another example where there's more on the bottom than the top, right? So let's do 3x to the 5th y squared over 9x to the 3rd y to the 4th. So we have 3x x, 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 y, y, 9x, x, x, y, y, y. Once you start doing that, you don't need to really add the dot in between. It just helps you remember that it's multiplying. But if you want to save time, you don't have to do it, right? So we cross out those 2 y's. We cross out these 3 x's. This divided by 3 is 1. This divided by 3 is 3. Right? This is just like a normal fraction simplification. Some people get those tripped up. So we're left with 2 x's on top. We're left with a 3 on the bottom and 2 y's on the bottom. Right, so sometimes we're left with variables on the bottom, and that's what that would look like. All right, so make sure you're doing the practice and checking the answer key, and you should be good.